All right. So let's talk about what an exponential equation looks like first of all. We can look at a very simple one. All right, so listen carefully. So this is a simple one, and it's going to get us through the rest of this and through the idea of the rest of this. So if I have this equation where I have, let's say 2 to the x is equal, um, let's say 2 to the fifth power, okay? And notice this is an exponential equation because you see the variable is located in the exponent. So that's an exponential equation. And this is an easy kind to solve. So I'm going to basically you're asking yourself, what must x equal? So what must x equal for this left-hand side to equal this right-hand side? Well, look at the bases. What do you notice about the bases? The bases are the same, right? So there's a one-to-one property. There's a property called one-to-one. Property that's called one-to-one. And that one-to-one property basically says what I'm about to tell you. If the bases are the same, so if a to the x equals a to the y, so the bases are the same, then the exponents have to be equal to each other. Then x must equal y. So this is a very simple one. On the final, it's not going to be that simple. You're going to see how it's going to look in a little while, but that's the idea. So the bases are the same. So to solve this equation, this exponential equation, the exponents have to be equal to each other. So in other words, x must equal 5. There's your answer. X is 5. 2 to the fifth equals what? 2 to the fifth. All right, so that's the idea. So let's look how it's going to look. So solve each equation. Solve each equation. And you want to, and the direction is going to say, for the most part, solve each equation by using the one-to-one property, using the one-to-one property. So what that means is this: if you're going to use a one-to-one property, you got to get the bases to be the same. That's what you got to do. So let's look at number one. Number one, let's suppose we have 2 to the 3x minus 1 equals 8. Okay? So 2 to the 3x minus 1 equals 8. So that is an exponential equation, right? You know it's an exponential equation because where's the variable located? The variable is located in the exponent. So it's an exponential equation. Now, if I'm going to use the one-to-one property, I need to make sure that those bases are the same. So this is a 2, this is 8. But what do you know about 8? You know that 8 is the same as 2 to what power? The third. So what you're going to do is this now. You're going to say, so this is the work. So this is how you're going to do this. You're going to say 2 to the 3x minus 1 equals, and you're going to rewrite 8. You're going to rewrite 8 so that way it has base 2. So 2 to the third. And now that looks like this. So now we can use the one-to-one property. So if the bases are the same, then what must be true? The exponents must be equal to each other. So the exponents must be equal to each other. So now you're going to write this. You're going to say 3x minus 1 equals 3. And you solve for x. So notice you have a very simple linear equation to solve for. So you're going to add 1 to both sides. So you get 3x equals 7, right? And then divide both sides by 3. You found x. So your solution is 7/3. You're done. Now let's check it. Now you're not going to have time to check this on the final. So don't even check it. You're not going to have time. You're going to run out of time. But on a worksheet, you have time to check these. So let's just check and see that this is true. What is 3 times 7/3? So you say I have 3 times 7/3, right? 3 times x, I'm saying x is 7/3. So 3 times 7/3 is 7, right? So 7 subtract 1, 7 subtract 1 is I'll make sure I did this right. Add 1, so I'm sorry, that's not 7. What's that? I put a 4 here. I meant that to be a 1, right? So 3 plus 1 is what? 4. So you get 4/3. I'm sorry, 4/3. All right, so 3 times 4/3. 3 times 4/3 is 4. Now what's 4 minus 1? Well, 4 minus 1 is 3, right? So the question is 2 to the third equal to 8? And the answer is yes, 2 to the third equals 8. So mentally, you can check these very easily. All right, but that's all you do. So the idea is to get the bases to be the same. Then you can use the one-to-one property that says if the bases are the same, then the exponents have to be equal. All right, let's look at another one. So this is number 2. So it's not difficult. It's just that you got to think about, well, how can I get those bases to be alike? That's the idea. So here's another easy one. So we're going to look at another easier one. So 3 to the x minus 1 equals 9 to the 2x plus 1. All right. So again, we have an exponential equation, right? So that's an exponential equation. The bases are not the same. I must get the bases to be the same. So you see how this 3, so 3 is a prime number, right? 3 is prime. So let's see if I can rewrite 9 as 3 to a power. What do you remember about 9? 9 is 3 to what power? The second. So I'm going to take 9, I'm going to write as 3 to the second because I wanted that base 3. So I get 3 to the x minus 5 equals, now be careful, here's what you're going to do. You need to do this because if you don't, you're going to make a mistake somewhere. You're going to rewrite 9, you're going to put that in parentheses, and you're going to put 3 squared, just like that. So that's 9, right? And remember though, your exponent is still 2x plus 1. So that's where I'm at. Now here's the next thing you're going to do. You're going to rewrite, see I'm boxing this off right here. You're going to rewrite this as one expression. Do you remember when you have a power raised to a power, what you do? So remember there was a property in a previous course that said if you have, let's say, b to the a power raised to the c power, then that's just b to the a times c. So when you have a power raised to a power, you multiply those exponents. That's what you're going to do here. Now be careful. Here's how you're going to write this. 3 to the x minus 5 equals 3 to the 2, this 2 here, times 2x plus 1, this times this. Now distribute. So this becomes 3 to the x minus 5 equals 3 to the 4x plus 2. So 2 times 2x is 4x, 2 times 1 is 2. And now you can use the one-to-one property. The base is the same, so the exponents have to be equal. So I'm going to say x minus 1 equals 4x plus 2. And all you do is just solve this simple linear equation. So I'm going to subtract x from both sides. So I get a negative 5 equals 3x plus 2. Subtract 2 from both sides. A negative 5 and a negative 2 is a negative 7 equals 3x. Divide both sides by 3. Your solution is negative 7/3. And that's all you do. So the idea when solving these exponential equations using a one-to-one property is to get the bases to be the same. And notice the process we went through. We had to think about some things, right? And we also had to use some properties from a previous course. A power raised to power you multiply, right? So make sure you're going to see this in these problems. So let's get another one. So here's number 3. So the more you look at and the more you do, the easier it becomes to understand. So here's number 3. So let's suppose in number 3, we have this problem. We have 4 to the 3x plus 1 equals 32 to the x power. Okay? All right. Now, so notice the base here is 4 and the base here is 32. They're not the same, right? So don't say 3x plus 1 equals x because that's not true. The only time those exponents equal each other is if the bases are the same. You're using that one-to-one property. So you may ask yourself, well, if that's a 4, can I rewrite 32 as 4 to a power? I don't know. Let's check. Let's try. 4 to the second power is 16, right? So that didn't work. So you cannot say 4 squared because 4 squared is 16. All right. You may say, what about 4 cubed? Well, 4 cubed is 64. So that's too much now. So you know this. You know that your base cannot be 4. Your base cannot be 4. In the previous problem, it was easy to see that my common base would be a 3 because 9 is easy. In your mind, you know that 9 is 3 squared. Same thing here. It was easy to see that your common base is just going to be 2 because 8 is 2 cubed. But in this problem, in this problem, there is no way you can write 32 as 4 to a power, as 4 to a power that's a whole number. There's no way. So what you got to do now is this. You got to rewrite 4 and 32. You're going to rewrite 4 and 32 as a different base. So think about 4. What do you know about 4? Well, you know that 4 is 2 squared, isn't it? Right? And what about 32? Is there any way I can write 32 as 2 to the power? Well, think about it. Let's try 2 to the third power. 2 raised to the third power is 8. So that didn't work. Let's try 2 to the fourth. 2 raised to the fourth power is 16. That did not work. Let's try 5. 2 raised to the fifth power. Oh, there we go. There's my common base. So my common base is going to be 2. So you're going to do this now. You're going to say 4. And remember a while ago when we rewrote this, what I told you to do? When we rewrote 9, I said make sure you put that in parentheses. Okay, because that's important because you're going to end up having a power raised to a power. So you're going to say 2 squared in parentheses. 2 squared is 4. Raised to 3x plus 1 equal, so there's your work. And then 32 we know is 2 to the fifth. So 2 to the fifth raised to the x. And the next thing to do now is to remember that a power raised to power, you're going to multiply these two exponents. And the same thing here. So in your mind, you know this. You know that this is 2 raised to the 2 times 3x plus 1, right? Equal 2 raised to the 5x. And now notice the base are the same, right? The base are the same. So if the base are the same, then what must be true about those exponents? Those exponents must be equal. So you're going to say 2 times 3x plus 1 must equal 5x. Now let's go ahead and distribute. So I get 6x plus 2 equals 5x. Let's go ahead and subtract 6x from both sides. So if I subtract 6x from both sides, I get 2 equals a negative x, right? 5x minus 6x negative x. But remember, you got to get x by itself, so you can divide both sides by negative 1. So a negative x divided by negative 1 is a positive x. 2 divided by negative 1 is a negative 2. All right. And let's check this one real quick, since it's just an integer. Let's just check in the original problem. So here's the original. 4 to the 3x plus 1 equals 32 to the x. So in place of x, I'm going to substitute negative 2. All right, so here's what we get. We get 4 to the, with 3 times negative 2 is negative 6, right? And then negative 6 plus 1, negative 6 plus 1 is a negative 5. And on this side, so I want to see if that's going to be this side. On this side, I get 32 to the negative 2. You may say, well, those don't look the same. Well, use your calculator. Watch. Use your calculator. 4 to the negative 5th. 4 to the negative 5th equals, you get this number, right? 0.00097. So just keep that in your mind. 32 to the negative 2nd, same thing. So those are equal. All right. So your solution is x equal negative 2. All right, let's do a couple more. We still have about 5 minutes, so let's do a couple more. So let's look at number 4. Number 4. So let's suppose in number 4, I have this one. I have 9 to the 2x minus 5 equals 27 to the x plus 1. All right, so notice the bases are different. So don't say 2x minus 5 equals x plus 1, because you know that's not true. That the only time those exponents are equal to each other is if the bases are the same. You're using the one-to-one property in that case. So you may say, well, this is a 9. Is there any way I can write 27 as 9 to a whole number? The answer is no. So you got to do just like we did a while ago. Think about 9 and 27. How can you write 9 and how can you write 27 so they have the same base? Well, look at the smaller one first, the smaller number 9. You know what 9 is. 9 is 3 to the 2nd power, right? So let's think about that 3. Is 27 3 to a power? Yes, it is. It's 3 to what power? The 3rd. So that's what you're going to use. So you're going to say 3 squared raised to 2x minus 5 equal 3 cubed raised to the x plus 1. And then you have a power raised to power, so you're going to rewrite this. You're going to say 3 to the 2 times 2x minus 5 equals 3 to the 3 times x plus 1. And now you're going to set those equal to each other because now you're using the one-to-one property because the bases are the same. So if you have an exponential equation and the bases are the same, then the exponents have to be equal. So you're going to say 2 times 2x minus 5 equals 3 times x plus 1. Get rid of the parentheses, use the distributive property. I get 4x minus 10 equal, and that's 3x plus 3. All right, so subtract 3x from both sides. See, I have this linear equation. So 4x minus 3x is x, minus 10 equal, and that's 3. Add 10 to both sides. There's my solution. My solution is 13. Okay, let's do one more, and then that'll be it. So that'll be number 5. So let's do number 5. So in number 5, we have this. We have 25 to the 2x minus 1 equal 125 to the 3x plus 4. All right, so you all can tell right away that you're not going to use 25 as that common base because there's no way you can write 25. I'm sorry, 125 as 25 to a whole number. 25 squared is way over 125. So think about how you're going to rewrite 25 and 125 so that they have the same base. So first of all, think about 25. You all know that 25 is what? 5 squared, right? 5 squared. And you all know that 125 is 5 cubed. Check yourself if you're not sure. Watch. 5 raised to the third is 125. And so that's what you're going to use. So you're going to use that common base of 5. So I'm going to write this as 5 squared raised to the 2x minus 1 equal 5 cubed raised to the 3x plus 4. And so now remember, a power is the power you multiply. All right, so you're going to rewrite this as 5 raised to the 2 times 2x minus 1 equals 5 raised to the 3 times 3x plus 4. And now you're going to use the one-to-one property. So if you have an exponential equation and the bases are the same, then the exponents have to be equal to each other. So you're going to say 2 times 2x minus 1 equals 3 times 3x plus 4. And then you just solve this linear equation, and then you're done. So let's go ahead and quickly do this. So using the distributive property, I get 4x minus 2 equals, and this is going to be 9x plus 12. Let's go ahead and subtract 4x from both sides. And so I get, this is 0, so I get negative 2 equals 9x minus 4x is 5x plus 12. Subtract 12 from both sides. I get negative 2 and a negative 12 is a negative 14 equal 5x. And then divide both sides by 5. I get x to be negative 14 fifths. All right, and so that was it. So that is how you're going to solve an exponential equation using the one-to-one property. So the one-to-one property is where you have to get the bases to be the same. All right. So on your final, there's one problem like that. So it's an easy one to get, right? All right. So let me go ahead and end this.